How are you? Like, let us suppose there is a problem like a car is moving, right? And let us say a body is moving. And there is another body B, which is also moving. Both are moving. And they are moving with the velocity. Let us suppose this is VA and this is VB, right? And if I ask you what is with respect to A, what will be the velocity of B? So how do you do that?
So it will be VB minus VA.
VB minus VA. So that you write it as what?
VAB.
VAB.
Yeah.
Or is it VBA?
Velocity of A with respect to velocity of B.
Yeah, so if you are saying the velocity of A with respect to B, so what it will be? Will B minus VA or will it be VA minus VB?
Then it will be VA minus VB.
VA minus VB, right? So you know how to do these relative velocity questions. Like, let us suppose I take two body. This is VA moving with velocity VA and this is moving with VB, right? Now I am asking you, do you find the relative velocity of B with respect to A? So as soon as I say you with respect to A, that means you will consider the body A to be at rest, right? So your frame of reference is now body A. You are on body A, right? So this has come to a rest. You have to find what I said, velocity of B with respect to A, right? With respect to A means you have now considering your frame of reference as body A. And when you are on this body A, what will be the velocity of B showing to you, right? So what you will do is that whatever velocity of this A is there, right? So that you will apply on B exactly reverse, right? So this will be VB minus VA. So this is with respect to the ground, right?
Right.
So one of the technique I'm saying you can use if you have to calculate the velocity of any body with respect to any other body, right? Whenever is that with respect to A, right? So what you have to do, you make the body A to be at rest. First thing you make it at rest, right? And the next thing is that whatever velocity of that rest body is that, you apply it on the other body in the reverse direction, right? So that will be VB minus VA, right? Now, if I ask you find the velocity of A with respect to B, right? So now what will I do? Which will I consider the frame of reference? I'll consider the frame of reference as B, right? I'll make the B at rest. Now, when you are at this body B, what will be the velocity of A being appearing to you, right? So this velocity you will apply exactly reverse now.
Right.
So now the velocity of A with respect to B is what? VA minus VB. So this is with respect to ground. Understood the concept? Similarly is with the acceleration. If acceleration is given, right? Let us suppose this is moving with acceleration VAB and this is moving with an acceleration A. I ask you find the acceleration of this body A with respect to B, right? So, or let us suppose I'm asking you the acceleration of B with respect to A. So what will you do? You will treat this A at rest, exactly opposite, you will apply this acceleration B, right? So now this will be what? VB?
Minus.
No, what you have treated it? A as rest, right?
Right.
So you're finding the velocity of B with respect to A. So A is at rest. Sorry, A is at rest, right? So A is at rest and the acceleration is this way. So exactly opposite you will apply here. So that will be VB minus VA, right? So that is how you can, solve some problems on based on relative velocity in 1D motion. Like let us suppose I tell you a car is there and this car is moving with a velocity 15 meter per second. This car, second car, which is the car B, it is moving with 20 meter per second. You have to find the velocity of car A with respect to velocity of car. Okay, you find it with B. B with respect to A.
5 meter per second.
Yeah. So as soon as I said with respect to A, you treat this as, at rest. You're sitting on it, you are treating it at rest. So this velocity will be applied exactly reverse to this body B. And this will be what? VB, we have to find the velocity of B with respect to A. So now if you see in this body B, that is 20 meter minus 15 meter, right? Exactly opposite I've applied. So that it gives you 5. Yeah, did you get that?
Yeah.
And let us suppose now I reverse this. Now A is moving 15 meter per second in this direction. Now you tell me what will be the velocity of B with respect to A?
35 meter.
Yeah, so this velocity I've exactly applied in the opposite direction to this body B. So now this will be 20 plus 15, which will be 35, right? So we'll do some questions on this. Then, there are some rain problem in 2D dimension. So we'll start with the worksheet. One by one, we'll deal with it, right? And then let's see. So far, Anvisha, how are you solving the relative velocity questions? The way I told you, or is just you are using the formula VAB is VB minus VA, VBA is VA minus VB. Students, they usually solve it using the formula. So how are you doing it?
I was doing it using the formula.
Okay, so let's see if you can do with using the worksheet. So you can, do both way. If you are perfect with formula, you can do it that way, or the easy concept is like you can do with this. Because sometimes, you get confused, like where to apply. Is it VA minus VB or VB minus EA? Whatever it may be, with respect to ground, with respect to whenever it comes, you treat that body as rest, and whatever its velocity or acceleration it is having, exactly that you applied on the other body in the reverse direction. Okay, now I'm just sharing it. So I'll be sending one sheet to you, Anvisha, today that will be on ray optic and wave optic, right? So that you solve on Saturday, Sunday.
10 seconds, option D.
Okay, so how you did this one?
The velocity, like if we take the train to be at rest, so the velocity of parrot will be 5 plus 10.
Train
So
is there and a parrot is there. Train is moving with a velocity speed of 10 meter per second, right? And the bird is flying towards this. Okay, this is moving north, so it is moving south in the reverse direction, 5 meter per second. Okay, so now how did you do this?
So I assume the train to be at rest. Uh, so the speed of parrot will be 5 plus 10.
Okay, so that is 15, right?
Yeah.
And they are
So
asking you the time.
time will be distance upon speed. So 150 upon 15.
Yes. So how much you got the answer as?
10.
Yeah.
Eight seconds.
Yeah. So what concept did you use in this one?
Like one train will be at rest. So the
Yeah.
total distance will be 200 meters and the
Mm-hmm.
total velocity will be 36 plus 54. That is
Yeah.
90 kilometers per hour. And then I converted it into meter per second.
Mm-hmm.
5 upon 18.
Yeah.
So 200.
Now this is the same. Only thing the data has been changed.
5 seconds. Option C. No,
10.
option D.
Yeah. 20. So how you did it?
Uh, like uh, the total distance of the bus will be 1000 plus 10 into 100. So
Yeah.
that should be equal to the speed of the scooterist into 100. So 2000 is equal to x into 100.
Okay. So like you haven't used the relative velocity concept, right? So how will you do it if you have to use the concept of relative velocity in this? No, it is at with what speed should the scooterist chase? Okay. Bus is moving with 10 meter per second. Okay, now how will you do with using the relative velocity concept? Let us suppose the scooterist is at v meter per second, right? So what is you bus? You consider it as a stop. Yeah, you take your frame of reference as a bus. So what will be the velocity of the bus of the scooterist with respect to bus?
V minus 10.
With respect to bus, right? Yeah,
Yeah.
V minus 10. Okay. Now the total distance is 1 kilometer. That is 1000 meter. So 1000 divided by V minus 10, right? And the time taken they have given us as 100. So if you solve it, it will come as 20.
20. Hmm.
Next one.
This is the same question.
Oh yeah, it's the same question. Okay, now this is okay in 2D.
Option A.
Yeah. So how you did this one?
We have to find the relative velocity of A with respect to B. So the direction of B will get reversed from west to east.
Yeah.
So
So it is
angle
right. This 3 kilometer and this way will be the 4, right? So the
yeah.
resultant is obviously 5 will come.
Hmm.
And the angle theta,
Uh,
that is
tan
your,
theta is equal to 3 upon 4, which is 37 degrees.
yes. And the direction you have to be seeing it, right? One is
Yeah.
north of east and one is east of north. So what is the direction? How did you decide it is north of east?
Because we are moving like upwards from east.
Yeah.
7 degrees.
Okay, the rain one. Rain is falling vertically downwards with 3 kilometer. A man walks in the rain with 4 kilometer. Now it is asking the velocity of the rain.
5 kilometers.
Yeah, so how you did this?
Um, like um, uh, we have to find the velocity of the rain with respect to the velocity of the
Yes.
man.
Hmm.
So the direction of rain will get reversed.
Yes.
But
Hmm.
uh,
That was simple. Yeah. Next one. How much?
10.
Yeah. So this one, how you did?
Uh, like uh, the rain is falling, so we have to find it with respect to man.
Yeah.
So the man's velocity I've taken as like the man is at rest. So the direction of rain will get reversed and it should only have a vertical component and not a
Yes.
horizontal component.
Hmm.
So the horizontal component will be 20 sine 30.
Yeah.
That is 10.
Okay, now the 41 question.
After 2 hours.
Yeah, next one.
Eleven.
Yeah, 43. Now you have to find the velocity of the train with respect to train B.
150 kilometer per hour.
Yes. And the second part was you have to find the velocity of, it's not given you, relative velocity of the ground with respect to train A.
60 kilometer per hour.
How will it be 60?
Minus
Velocity of ground with respect to A.
0.
No, no, no. See the direction properly. Velocity of ground with respect. So train, you will treat it at rest.
Okay. Minus
Apply
60.
minus 60.
Mhm.
Yeah. Is it visible to you?
Yeah.
Okay.
Six seconds.
We are doing 20. Okay.
44.
Yes, 6 seconds. Next one, 45. So what will be the time taken for the sound to travel from the gun to the tank?
1.5
Yes, that
into
is
3.
2.1 minus 0.6, right? 1.5. Okay, then velocity of sound, you can find the distance.
510.
Yes. So what will be the velocity?
850 meters per second.
Yeah, 850 meter per second. 46 one.
Root over V1 square plus V2 square.
Yeah,
upon
that
2.
was simple. Yeah. Next one.
700 kilometer per hour.
Yes. Next one. So this find relative velocity of B with respect to A, of ground with respect to A.
Relative velocity of B with respect to A is 144 kilometers per hour.
Yes.
Relative velocity of ground with respect to is minus 90 kilometer per hour.
Yeah.
Option C is
Nick,
because
yeah, it's incomplete. Yeah. So it's saying you have to find the velocity of the monkey running on the roof of the train against its motion with a velocity of 18 kilometer per hour with respect to training.
Hmm. 126 kilometer per hour.
One?
126.
No, it's 36 answer. Check it again.
Monkey is running in the direction of train A opposite to train B.
Velocity of monkey running on the roof, it is 18 kilometer against is opposite to train A it's running.
Oh, okay. Then I'm getting 18.
So now 18 kilometer per hour, they have given it with respect to train A, the monkey is running, right?
Right.
So what they are asking, they are finding velocity of a monkey running on the roof of the train as observed by a man standing on the ground. So you have to find the velocity of the monkey with respect to ground, right?
Right. Okay, with respect to ground.
Because a man is standing on the ground.
Okay, so that I'm getting as okay, yeah, then I got 36.
Okay, now second one, what you said, the answer relative velocity of ground with respect to B.
Minus 90.
That is plus 90. Now it is saying it's moving in the opposite direction, that is left hand side, 90 kilometer.
Yeah.
So with respect to ground, they are saying. So you are at ground is your frame of reference. Now that 90, you will add it to the ground in the opposite direction.
Yeah.
You get that what I'm trying to say?
Yeah.
So that will be plus 90. Okay, this one we have done. No? This one. 1.30.
.1 meter per second and 0.5.
Yeah.
Five kilometer per hour.
Yes. Second one.
Five kilometer per hour.
Yeah, that is option A, right? Next
Right.
one.
(10√3). Option B.
Yeah, next one.
Option A.
Yeah, option A is right. Okay, so this completes our sheet. Now, do you have the mobile with you, Anisha?
I get it.
Okay, you get that? I'll send one more sheet. Yeah. Did you get it?
Yes.
Okay, now you see that vector starting with 1. So I've sent you the vectors, then you do till 1 to 13. Yeah. Are you there, Misha?
Sorry, ma'am.
Yeah, it's okay. So 1 to 13. Start with the vectors.
Option A, 90 degree.
Yeah, option A. Next. Second one.
Option C, pi by omega.
Yeah. Third one.
Option C.
Yeah.